Huh. That's super weird. Oh, that's why. Okay. Hi everybody. How's it going? Um, hmm. Hey everybody, good morning. How's it going?
All right.
Oh, okay. Again, I'm like resetting my computer from having it downstairs yesterday, so I'm always sketchy about having the settings right for audio and such. Nonetheless, today we're going to do a couple warm-ups, some harder type questions using these counting techniques. Both of these questions that we'll be discussing this morning use kind of a mixture of these two skills, right? These two techniques. So for both of these, you'll have to do a little bit of permutation, a little bit of combination, and also a little bit of multiplication principle in order to figure out the total number of possibilities. So item number one here, you have 6 earrings, 4 necklaces, and 4 rings. If you wear 1 pair of earrings, 1 necklace, and 2 rings, one on your left hand and one on your right hand, how many ways can you wear your jewelry out of these 14 pieces here? And the reason why I mention that, like when you wear your rings, that you are putting one on the left hand and one on the right hand, why would that detail be given? What is the point you think of providing that information? There is a mathematical point to saying that of the way that you are going to wear the 2 rings, one of them is going to go on your left hand and the other one is going to go on your right hand. Why would I give you information about the order?
To use the permutation formula, not the combination one?
Precisely, because when it comes to counting, right, if we're just going to take a pair of rings and put both of them on the same finger or whatever, in that case, the order wouldn't matter and we're going to get less total possibilities. But by saying that wearing a ring on the left hand as opposed to on the right hand, right, by making the order matter, we are then counting permutations and not combinations. So item number 1 there, figure out how many different ways this jewelry can be worn based on the given information. And then in item number 2, you are getting a government license plate with the following rules, just because different states do license plate arrangements differently. And you can also get special license plates for various reasons. Certain government jobs will come with special license plates that are like California exempt or whatever, or even being a veteran gets you a special plate, or being a past Olympian gets you a special plate. Nonetheless, here are the rules for this special government license plate that you are being issued. We're going to start off with 3 numbers. And these numbers could be anything except it can't begin with 0. And then over here on the right, 1, 2, 3, 4. The last 4 are letters. However, of these letters, there are no repetitions. Actually, let's just do just letters. Just letters. I think it's doable either way, but we'll keep that part simple. So that second part over there on the right is just going to be letters. So go ahead, deal with these 2 counting questions, and then we will go over them. In the meantime, y'all saw the news yesterday about the SpaceX launch?
Yeah, I got postponed because of weather.
Yeah, I'm following that news item real closely because I still have a fantasy that I can still be an astronaut. I'd have to get my pilot's license like on my own money for sure. That would be a requirement. But if I get it done, I think I would stand a decent chance. There being private space flight is big because right now, like the US government really only needs 50 astronauts total. If we get to a place with the economy where we're going to space with private corporations, it could lead to a bunch of employment of astronauts.
Yeah. Yeah, you never mess with the weather, even for rockets.
Yeah, so even though you're only dealing with the weather for the first like 45 seconds and then you're up above the atmosphere.
Yeah, exactly.
But it's like, it could be super
For
dangerous trying to get through the atmosphere if the atmosphere is being uncooperative. Other thing while y'all work on these questions is picture day, like I mentioned on the thing. So sorry to do it twice. I need everybody to take a minute or so while y'all do your warm-up to get decent real quick. Because you ever do that thing where you don't follow all the instructions on an assignment and you have to do it again? Well, I was given the assignment of taking class photos and I didn't read the instructions completely, and now I have to do it again. They didn't want me to share the whiteboard in the background. They really do want just class pictures of everybody like on Zoom in just the people window. So yeah, take a minute. We'll take the picture before we go over these 2 questions, but just take a minute, work on these, and then after that, we'll spend some time working on the homework together. I'm like super glad to answer any of the questions from it, just because the first, how do y'all feel about the SAT requirement being eliminated by the UCs?
It's better because it's not really, it's just how well
there's not SAT?
It's not really determining anything.
Oh yeah,
It's how
dog,
well
if
study for
you
the
didn't
SAT.
hear, big news,
Yeah.
the UCs will not require the SATs, it seems like ever again. So they didn't require it this year for y'all like applying as seniors in the fall. because of how difficult it is to get an SAT right now, even though the SAT said that, oh, when we come back, we'll have them weekly. But the UCs took the extra step and they were like, it's a garbage test. We're just not going to require it anymore, period.
That's insane.
They also sound like the second motivation for why they're doing this is that they're probably going to inevitably introduce their own standardized test for admissions. But y'all won't have to take that. I don't think it'll be ready in time for the fall. And they already said that they won't be requiring any score submissions this year. Okay, we'll take attendance, we'll take the photo, we'll bust through these warm-up questions, and then preferably for the rest of the hour, I'll do homework for you, yeah.
Yep.
Oh my God, it's already Thursday? Okay. I'm gonna stop sharing for a second here. Gonna set that full screen. Close the participants window. Okay. Could I have everybody turn on their cameras? I won't be rude and just like turn on all or whatever. Tight. Oh man, anybody have one of those gamer chairs that looks like a race car seat?
Yes.
No? Oh wait, who said yes?
William.
Oh yeah? Is it good? Is it actually worth getting one of those?
I mean, I'm not sure if
No, it isn't. I promise you I have one. It's not comfortable.
Oh yes! Yes! Gamer chair. Okay. That's amazing.
Look, I could pull out a footrest.
Oh hell yeah, it could actually double as a barber's chair. That's actually kind of dope. That might actually be good for getting my hair cut. I kid you not, upon leaving, I like stole my chair from work and brought it home just because it was better than my home office chair. So I have a little bit of AGBU here with me. Don't tell anybody. I'm still waiting on 3 more webcams and then we can take this screenshot and be done with this silly project. Sorry, 4. Three. Two. Almost there. I could be rude. I could hit Control A for all and then right click and then start video on everybody from here because I own the thing. But that seems like a nightmare and I don't want to do that to people.
Seems like he's not there.
Oh, I know. Yeah. I get a bunch of that on here at random times. My favorite is when people leave their microphones on and they don't know that their microphones are on. I once got to listen to a full 2 minutes of somebody playing whatever the Call of Duty Battle Royale mode is. I already forget what it's, Warzone. I definitely was listening to somebody yell really loud about Warzone because they were like, oh, the gas is coming in. I was like, yo, dog, this is supposed to be geometry. Two more. So close. One more. Otherwise, I'll have to rely on the powers of Photoshop. All right, I got one more joke. Hey, actually, no, I'm not going to go there. That's not a good joke. All right, we're just going to roll like this. I think this is as close as we're going to get. And then, like I said later, I'll try and rely on the power of Photoshop. Everybody be pleasant. Pretend stuff is normal for a second. Imagine you're at a restaurant for the first time in months and the food is also good. Okay, print screen. Thank you.
All right.
Let me also not make the huge mistake of not saving that. That would be a big oof. Okay. Put it into Photoshop, save as, desktop, precalculus.png. Okay, amazing. Okay, God, I would bemoan having to do that again. Anyway, let's go ahead and get rolling. So item number 1 here, you have 6 earrings, 4 necklaces, and 4 rings. And we want to try and figure out how many different ways you can wear your jewelry. So when it comes to trying to combine these 3 different things here, this is just a regular old multiplication principle question. So that is to say, if I want to know the number of ways that I can orient my jewelry, it's going to be the ways that I can orient my earrings multiplied by the ways that I can orient my necklaces multiplied by the ways that I can orient my rings. And the first 2 are pretty straightforward, right? I have 6 pairs of earrings and I can only wear 1 pair. I have 4 necklaces and I'm only going to wear 1. I'm not going to stack them. And then for that 3rd position, what's the deal? How many different ways can we wear our rings?
2.
I don't think it's that simple. So I have 4 rings and I'm going to wear 2 of them. But
Is it
I said that the order matters. How can we calculate orientation possibilities when it comes to cases where the order matters?
Use permutations, right?
Yeah, we're going to use permutation here. So how many rings do I have?
4 rings.
And I'm going to permute them and pick how many out of the 4?
Well, two out of the 4.
Perfect. So this right here, this product, this times this times this will tell me how many different ways I can wear my jewelry. So again, it's kind of a combination of a permutation along with the multiplication principle. I am considering the ways I can wear my earrings, the ways that I can wear my necklaces, and the ways that I can wear my rings. And then after considering them independently, I multiply them. The extra wrinkle being that If I'm going to say that it's different if I wear my rings like this, left hand, right hand, versus swapping the hands, right hand, left hand, that's actually going to add possible combinations of rings that wouldn't have been counted otherwise. So it's going to be 4, and then math, probability, P, 2. So with this extra rule set, there's actually 12 different ways that I can wear my rings, times 4 times 6. And so with this small amount of jewelry, there are actually 288 combinations, though just like yesterday's examples with mixing and matching suit parts, that doesn't mean they're all going to look good. Mixed gold and silver is real hard to pull off, right? But just in terms of raw combinations, 288. Is that okay?
Mr. Robinson,
Yes,
if you don't mind, can you do the 4 permeability 2 in the calculator again, please?
for sure. Yeah. So you plug in the 4 part first, and then math, and then I go left 1 menu to probability. You could also, like, from math, go right 2 or whatever, but know that it scrolls endlessly. And then probability, you go down 1 to NPR. And then, so this is saying 4 is equal to N, and then permute for R objects, and then plug in 2, and then it works.
Perfect. Thank you.
And also, because of the way that this thing works, and I guess technically you can't take the factorial of a negative number, if you ask it a nonsense statement, it will tell you as such. So if I were to, for example, plug the numbers in the wrong order, if I were to do 2, P4, this doesn't make sense. This is a nonsense statement from a counting principles technique. What it's saying is, I have 2 objects. Please produce for me permutations in sets of 4. Can I select 4 objects from 2 objects?
No.
No, that doesn't make sense, right? It's like, hey, how many ways can I arrange these 2 pens in an order of 4? Yeah, it's the wrong question about that. If you do that, it'll give you a nonsense answer. You just get 0 out. So if you ever get 0 out of an NPR or an NCR, you've made a mistake in the way that you enter it.
On a TI-84, it gives like the newer version. It just says error.
That's a better response. That's what it should say. It all depends on the version that you're running, but either way, 0 or error, neither of those really make sense.
Okay.
And I'm sorry, 288. Always give units. Looks. Anyway, item number 2. We are getting a government license plate with the following rules. Numbers, 3 numbers, but they can't begin with 0. And then letters. And then I'm going to show you guys the version of this that we were looking at before of how we would deal with this if it was letters without repetition. Just kind of an extra wrinkle that would change the way that we would think about this. So letters without repetition. We'll do this as kind of a modified version of the question B down below. Anyway, so how do we consider this? What's a good way to figure out the original version of this without this additional wrinkle here? So first, how do I figure out how many different ways that I can get a set of 3 numbers that don't begin with 0?
Well, we have
It
10
goes from
numbers.
1 to 9.
1 to 9, right?
Right. So in this first position, then we can't have a 0. We can only have the digits between 1 and 9. So how many digits are there from 1 to 9?
9.
9. So for this first part, figuring out the number of ways that we can come up with numbers, in that first position, there are 9 possibilities. And then how many possibilities are there in that second position?
26.
8. 8.
Oh, never mind.
Here?
Is it 8?
8.
No.
Or it's still 9 because you can put 0.
If you can put 0, how many digits are there? How many digits are there
10.
from 0 to 9?
Can there be the same number?
Yeah,
No.
I never said it was
Then
numbers
10.
without repetition. Yeah. So
Then 9.
in the first position, there
No,
can
it's
only be
10.
9 numbers. In the second position, there can be 10 numbers. So in this first position, we could have any number from 1 to 9. In this second position, we can have any number from 0 to 9, and there are 10 digits, including 0. And then what about this third one?
10 again.
Same thing again. So 9 times 10 times 10. So that product right there will give us the ways in which we can produce the cluster of numbers at the start. Up next, letters, and it's just 4 letters. So what's that going to be? How many different ways can we orient that?
26 times 4,
So it's
104.
26. It could be in that first position. How many digits can, or how many letters can be in the second
25.
position?
25.
This is not letters without repetition. This is just letters.
Oh, 26. It's 26.
Times 26 times 26, which is actually 26 to the 4th, not just 26. So this is to say that the number of ways that this special government license plate can be written out is 9 times 10 times 10 times 26 times 26 times 26 times 26. A very, very large combination of numbers. This is why license plates never get repeated within a single state, because there are so many possible combinations that we still haven't looped all the way back over on itself. Or when they get close to the end of a cycle, they will change the rules of the orientation of the license plate completely so that they can invent some new set of combinations. Now let's say we add this additional wrinkle. The letters that are placed in here must be placed in without repetition, right? And this will lead to a pretty different solution. So without changing the rules for the numbers, that won't change, right? So that'll be 9 times 10 times 10. But if we force ourselves to use these 4 letters without repetition, what's a good way that I could represent that?
26 factorial over n minus r factorial.
I guess, and those formal definitions are good if you're going to manipulate those things. But so long as we have calculators, we really don't have to use the formal definitions when we plug stuff in.
So then
Just 26 times 25 times 24 times 23.
I like that. So one way to think about it is that if you choose your first letter and that letter happens to be M, you can't use M again. So in your next position, you must choose one of 25 letters. So this could be 26 times 25 times 24 times 23. This will give you a correct answer. What's the other way to consider what we're doing here, picking letters without repetition?
Permutation? Using
Correct. We could also write this as a permutation in that case, right? So that is to say, how many objects are we mixing around?
26.
And of these 26 that we're going to put in some order, because in this case it's a license plate, the order matters, right? Having the cluster of letters A, B, C, D is different than having the cluster of letters D, C, B, A. How many objects are we permuting? 4. And you'll notice that by the formal definition of permutation, it would give you this, right? If you did the division, or if you are feeling lazy, you can just show this in your calculator. Both of these in your calculator are exactly the same because they both represent the situation. So 26 times 25 times 24 times 23, 358,000. And then 26P4, same thing, but the point in understanding this shortcut command is so that you can figure that out quick. And so, in this case, by adding this extra rule, we remove a lot of possible combinations. We remove about 100 million combinations just by forcing the extra rule that the letters cannot repeat. Weird stuff. Anyway. This time is yours to work on the current homework assignment, and if you have any questions, just holler at me. I would love to work some of them out live. We have about like 25, 30-ish minutes left to work, so I don't know, maybe I could do most of it.
Mr. Robinson?
Yes.
For part A of like number 2, why couldn't you use combination for like the letters? Like, why couldn't you use the NPC or NCR or whatever?
In part A of 2,
Yeah.
there are n ways that event can.
Oh wait, no, for the do now, like not for the homework.
Oh, I'm sorry. Part A for the do now.
Computation is when there are no restrictions, right?
Like,
So,
why can you use
so here?
combination for that? Yeah.
Oh, now I understand. Okay. If you were to use combinations, then it would only count up combinations of 4 letters. But in a license plate, it's implied, I guess, that the order is necessarily relevant. That is to say that if you were to like try some different stuff that you could plug in here, for example, the trial A, B, C, D versus the trial D, C, B, A, both of these are the same combination. They're both the same grouping of 4 letters, but in terms of license plates, they are different license plates, right?
Mhm.
Same combination, different permutation. So if you were to if you just use 26 C4, then it's going to count both of these as being one thing, but they're not.
Oh, okay.
Yeah, I guess that's a case where order being implied is implicit.
Mr. Thompson, can you do something like number 35?
Mm-hmm.
Because I'm not quite sure what's going on there.
Huh, that is a spicy one. Let me,
Yeah.
it's doable. Let me do a little bit of scratch work before I say something dumb. Hmm. Hmm. I could brute force it, but I'm trying to think of an elegant way to describe what the deal is. Oh, you know, I guess I got it. I guess this is the brute forcey way. So this is saying that some set of possible digit combinations, right, has 900 million whole numbers. So 900 million elements in the set.
So those are the spaces, right? Like the
No, this is saying if I were to make a list of numbers, the list is 900 million. If I was to make a list of numbers, right, like 1, 2, 3, 4, this is saying that there are 900 million numbers in that list, not that that's the length of any given digit.
Oh, okay.
So how many digits long is one number from S if there were necessarily 900 million digits in the set? And they want us to use the fact that a whole number doesn't start with the digit 0. So that's kind of an enforced rule that they're giving us here. So here's how I would figure this out, though you're not going to like this because this is the part of math where maybe regular old algebra doesn't help. What we're doing is a little bit more subtle than that. We're doing like logic and reasoning. Here's the way in which I figure this out. So the first digit can't be 0, right?
Right.
So how many different numbers can sit here?
9.
Mm-hmm. And then what about that next position? Really, the only rule they're giving us for this is that the first digit can't be 0, but there's no rules for any of the other digits. So how many numbers could sit in that position?
Right. So 10.
Uh-huh. And so to do the combination stuff, right, every other position is going to add an additional factor of 10. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9 spaces worth of 10s. So that is to say that it's going to be 9 times 10 times 10. Oh, I'm sorry. This way. 9 times 10 once, times 10 again, times 10 again, times 10 again, times 10 again, 10 again, 10 again, times 10 again, right?
Mm.
So the thing that produces a combination of 900 million different digits in the list is the number of digits that are in any given number. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep, so that'll do it. So the answer is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Every single number in the list has to be at least 10 digits long if the list itself is 900 million digits.
Okay. I understand what you did, but so pretty much the fundamental thing, you're kind of dividing 900 million by the number of space. No, I'm kind of.
No, I wouldn't say that. This is, so here, let me give you like a problem solving equivalent, right? So the first thing we teach you to do when it comes to the circle equation is I tell you a circle has a radius of 2. What's its circumference, right?
Mhm.
And then it's really quick that it's 4 pi because you have an equation there. And then if you get good at geometry, then you can deal with questions that are like, hey, the circumference of a circle is 12. What's the radius? What's the wrinkle there? What's the difference between that and the first question I asked you?
That there's no like clear-cut formula for it.
No, there is. There is. I tell you a circle has a circumference of 12. What is the radius? What are you being asked to do as compared to that first question?
The first one's already has pi for you. It's simplified. Right?
I give you this equation and I tell you that it's true. And so the first version of the question I ask you, the level 1 question, is I give you R and I ask you to solve for C. That's plugging and chugging.
Right.
I tell you C is 12 and I ask you to solve for R. What is the difference?
Yeah. So you have to move it around to find R.
Right, but you must admit it's still the application of the exact same equation, of the exact same relationship, right?
Yeah, I understand. Right.
So this is the same notion. The only difference is that when I talked about the counting principles themselves, every single one of those is like a recipe where you can take the number of elements, and if you cook it up right, it'll tell you the total number of possibilities. In this question, they're reversing it. So instead of giving you the piece that you plug and chug, they're giving you that object on the left-hand side. In this case, they're telling you straight up, there are 900 million possibilities. So therefore, what is the structure of the set?
You're kind of moving backwards.
Exactly, yeah, you're working backwards after being given an answer. And honestly, the only thing that makes this question reasonable to ask is the fact that if it's really just a structure of digits, well, there are 10 unique digits, so that makes it pretty straightforward to figure out the rule of the set. If this was the same thing and it's like, hey, there's 328,588,800 different words, how long are the words? I don't know what that is. Like, that would be way nastier to figure out because letters come in sets of 26.
It's not as simple as just 10.
Yeah. Part of this is actually what it means when we talk about living in a base 10 number system. It isn't the fact that the numbers restart at 10. It's the fact that we only have 10 characters to represent different digits. but that's the actual definition of base 10.
Cool. All right. Thank you.
It's a good question.
Mr. Robinson,
Yes.
can you explain number 7, please? I'm a little confused.
Oh, okay. So in question number 7, we are being asked how many ways there are to choose a positive or an odd number. So for question number 7 here, we're being asked to consider the word or. So for set B, this is going to be equal to negative 23, negative 16, negative 7, negative 2, 20, 36, 48, and 72. For some reason, this is our cluster of data. And so the deal with this question is that when it comes to the word or, and this isn't a thing that's really an equation, this is the logic of the situation. If any positive number were to satisfy our condition, then here are the following things which satisfy our condition: 20, 36, 48, and 72. And then for that second one, odd, here are the numbers that satisfy that condition: negative 23, negative 7. Oh. Wait a minute.
Negative 16 and then negative 7.
Is that the whole question?
Yeah, I'm a little, but it also says choose a positive or an odd from A. It's giving us set B, but it's telling us to choose from A, and I'm a little confused by that too.
I think that part's a regular old vanilla typo. I think it's supposed to say how many ways are there to choose it from set A.
Do we just add these two, like 4 and 2, basically?
Yes, yeah. So this is addition principle. The word or typically means to add. The word and is what lends us the multiplication principle. So yeah, all it's saying is that of this set of elements, by the use of that word or, there's actually 6 digits that can satisfy it. Is that okay?
Yeah.
That the answer is just like 6 digits that can satisfy it? I'm gonna mess this question up now because I thought it was a better question than this. Here's what I thought it was getting at, and this is the thing worth thinking about. let's say that I'm going to change this question a little bit. I'm just going to change the list of numbers here. And I'm also going to include the following 79. Why is that an interesting number in this question?
Because it's both positive and odd.
Yeah, because it fits in both, because it would be 79 and it would be 79. It fits the rule set on both sides here. It's both positive and it is odd. Does that make the answer to the question then that 1, 2, 3, 4, 5, 6, 7, 8? Does that now make our answer 8?
No,
No, why not?
you can't choose it twice.
Yeah, it's not there twice. So be careful when it comes to the use of the word or for adding up sets to omit repetitions like that. So be careful of the case here, right? Beware. Plus and odd, because if it's both at the same time, you might accidentally double count it.
Wait, Mr. Robinson, then how do you know where you're gonna put it, if positive or odd? Doesn't matter?
Doesn't matter at all, no.
Yeah,
All
it
I'm
doesn't
saying is
matter.
like, don't count things that count in both categories 2 times.
Okay.
Okay, thank you.
Yeah. Oh, also, I guess I was a little bit ignorant. Let me talk about a deck of playing cards real quick, because now that we live in the future, I'm not sure that everybody is on equal footing when it comes to decks of playing cards. Playing card questions are really common. And just so you know, here is the structure of a standard deck of playing cards. There are a few in this homework. There will be a lot more in the near future. When it comes to your standard deck, standard deck does not include jokers. So a standard deck is 52 cards, which is 4 suits. And the suits are, I should draw it in line. Diamonds, clubs, which I suck at drawing. I just draw 3 circles. I'm sorry. Hearts and spades. And then of the 4 suits, there are 13 cards in each suit. And those 13 cards are the numbers 1 through 10. And then Jack, Queen, King in that order. Typically, if you need to know the rules of the game, I'm not going to expect, like, I'm not just going to ask any questions that are like, hey, what's the deal with poker? I will very clearly define for you what the rules of any given card game are before I ask a card question, just because there are so many different kinds of poker or whatever game you want to try and talk about that I'm not going to expect you to think that I'm not going to expect you to agree with me on exactly what poker is. I will tell you in any given question what kind of hand we're playing with. So I guess real quick question. Let's say that you are dealt 2 blind cards. So dealt 2 blind cards, which is just the same thing as saying that the order doesn't matter. How many ways can you be dealt